there's one other measure of position that we need to talk about, and that's the median. The median measures kind of the center of the data. It's a measure of the center of the data. What the median does is it splits the data into two groups. So you have 50% that are above the median and 50% of data values that are below the median. The median splits a data set into two groups. So 50% of the data set is above the median. And 50% of the data set is below the median. Okay? And as we said, you could think of the median as the center of the data. It's the value in the middle, though technically the median doesn't have to be a value. It's actually in the data. Okay? Let's look at a couple examples to kind of illustrate what's going on. We'll look at this by hand. Okay, we'll calculate this by hand, and then we'll look at how we can calculate this using R. Okay? So say we have a data set. Here. We have this data set here. Now we want to find kind of the middle value so that half of the data is above and half of the data is below. Okay? First step, if we're going to do this by hand, is to put the data in order. Okay? So if we put the data in order, and we get something like this. Okay? So this is unordered data. And this is the same data in order. Okay, so we want to find the value in the middle. So let's kind of work our way inwards. Okay, so we start at the edge on both sides. Okay, and then we go 1 in, 2 in, 3 in, 4 in, 5 in, 6 in, and then notice there isn't a individual value that's in the exact middle, right? If we do have a value that, and these arrows meet at the same value, that would be our median. But in this case, if we're looking for that median, there isn't one value that we settle on. We kind of get stuck, right? This one's a little too far to the left of the center. This one's a little too far to the right of the center. We want the exact center. We want something that's right here. Okay? When this happens and we don't end up in the exact middle of something, we take the average of the two values that are closest to the middle. So in this case, we don't have just one value in the middle. We have two values that kind of are together in the middle. So we're going to take the average of them. Okay? So the median would be, and I just add them and divide by 2. That's how I take the average of two numbers. Okay? And it turns out if we take the average of this, we end up getting 7.0. You can throw it into your calculator if you want to, but we end up getting 7. Okay, so the median is 7. And half of these numbers right here, these 1, 2, 3, 4, 5, 6, 7 numbers, these 7 numbers are less than 7, and these 7 numbers are greater than 7. So 7 is the median. It is in the middle. Half the numbers are above, half the numbers are below. Okay? We could also calculate that using our quantile function once we realize that the median is the same thing as the second quartile. Okay? Remember, the second quartile is the 50th percentile. This value right in the middle has a lot of special names. Okay? When we're talking about it all by itself, we tend to call it the median. In all these cases, the idea is that 50% of the values are below that number, 50% of the data values are above that number. So let's confirm the result we calculated by hand here by taking this data, even unordered, and using our calculator. Okay? So I got my calculator here, and let me get my data. So I'm going to combine my data into a list. So I use my C to combine. In the parentheses, I have my data. Notice I haven't bothered to put it in order. The computer can do that. That'll save me some time. Okay, and I don't want really, this is just some random numbers, so I'm just going to call it X. Don't need to give it a special name. I'm going to use the quantile function. I've stored my data in a variable X. I've named my data X. Probs equals 0.50 because I want the median. I want the value that is the data value so that 50% of the data values are above, 50% are below. So let's see what we get when we evaluate this. And we get, let me shrink this a little, the 50th percentile is 7. The median is 7. That agrees with what we calculated by hand. Okay? So it's important to know how to calculate the median by hand, but most of the time we will use the computer to do it. Okay? Let's look at one more slightly trickier example. Okay? For the following 13 real estate prices, calculate the median. So calculating the median for this isn't so hard. Even if you wanted to do it by hand, it wouldn't be outrageously difficult. There aren't that many data values we have to look at. If we wanted to calculate these by hand, we would line these up in order and then find the value in the middle. Or if 2 values are in the middle, take the average of those 2 values, like we did in the last example. Okay? Now, what if we want to use our calculator for this? Okay? Well, if we want to use our calculator, we have to write the data in a way that the calculator likes. Right now, this data, if we just entered the data like this, our calculator is going to freak out. Let me show you what happens. Okay? So let me pull my calculator over here, and let's try to just create that list of data directly from what's going on here. Okay? So I've just copied and pasted exactly the list of numbers we have here. Okay? I'm going to call it a name. These are real estate prices, so I'll call it prices. Okay? I've named my list prices, and I'm not even going to try the quantile function yet. Let's see what happens with just this list when I click evaluate. It gives me this big, long, nasty, scary looking error. Okay? What happened? Well, there's a couple issues here. First, we're trying to give the calculator, the computer, a list of numbers. Okay? It doesn't understand that we're trying to give it money. Okay? It doesn't need these dollar signs. So when we provide it these lists of numbers, we want to take out the dollar signs. It's not going to understand the dollar signs. Okay? So we're going to remove all those dollar signs. Another thing is, notice the numbers are separated with semicolons. Well, that's not how we separate lists of numbers in the computer. We use commas. And so when the computer sees the dollar signs and the semicolons, it doesn't know what to make of it. Okay, and so it freaks out and it gives us that big long error message. So we need to make sure that we are putting in data the way the computer likes. Okay, no dollar signs and commas to separate the numbers. Okay, so let's take a look at what that looks like here. Okay, so I'm not going to do all of these yet. Okay, let's just focus on these two, because I want to show you there's one more issue we're going to have. So take out the dollar signs, replace the semicolon with a comma. Now if I evaluate this, it's not going to give an error, but look what it does. Okay, instead of 2 big numbers, it gives us 4 smaller numbers. Okay, so it's not 389,950, it's 389, then 950. When the computer sees the comma, it thinks, oh, you are telling me the next number in the list. Okay, the computer only uses commas to tell you to say that list item is done, this is the next thing in the list. So it thinks 389 is the first thing in the list, then there's a comma, so 950 must be the next thing in the list. Okay, that's not what we want. We want all of this to be one number. We want all of this to be one number. When writing numbers in the computer, you cannot use commas to represent the thousands place or the millions place, or whatever. Instead, you just leave them out. So if I want the number 389,950, I leave out the comma. Okay, just one big number. 230,500, leave out the comma in the thousands place, just one big number. Okay, commas are only used to separate different numbers in the list. Okay, so now that we understand how to enter the data correctly, I'm going to copy that list again, and we are going to change it so that the computer likes it. So that means we're going to get rid of the dollar signs. So get rid of all those dollar signs. And now I'm going to get rid of the commas marking the thousands place or the millions place. We know the comma should only be used to show, to mark where the next number in the list is. Okay, so get out all the commas marking thousands places and millions places. Now we do want commas to separate the different numbers, not semicolons. So I'm going to swap out all these semicolons with commas. Okay. Okay, now this is a list that the calculator will like. All right, so now that we have that, we can finally calculate the median using the computer. We'll use the quantile function. We'll tell it what lists of data we're interested in, and we want the median, so that means we want the 50th percentile. So probs equals 0.50. Okay. So the median is 488,800. So the median, and we sometimes notate the median with M, is 488,800. And I could add back the dollar sign and the comma once I take it back onto my paper to interpret it. Okay, that's the median. So that means exactly half the data values, these data values, exactly half of them are above and half of them are below. Half the data are below the median. Okay, we could see this number right here, 488,800, which means if we were to line up all these in a row, this one would lie right in the middle. Okay, we wouldn't have two in the middle, we would have just one number in the middle, and that's it.